Good morning, scholars. We're going to be doing a quick video, a real quick video on congruence. What do we mean when we say that two or more things are congruent? The word congruence means to agree, to cooperate, to get along, right? That's the meaning when we use it as a word regularly when we're speaking. And remember, we say that many of our mathematical terms, if we know the actual meaning of the word as used in the regular language, we can go a long way in understanding what the term means in mathematics. So if congruent means, in general usage, to agree, to get along, to cooperate with each other, to fit nicely together, right? It translates to the use of the word in mathematics. It's not always this way, mark you. It's not always this way. There are words that are used in mathematics that have a different meaning from how they are used in the English language. But most words, most terms that we use in math abide by the general definition of the word as used in the regular language. Congruence is one of those. So when two things are congruent, they fit exactly over each other. They are exactly the same size and shape. They fit nicely over each other. We can put them on top of each other. You're not going to see anything, any outline coming off. They are exactly the same. And this says the orientation. What's the meaning of that big word? Orientation. If you check your dictionary for orientation, go and check and see what it says, right? Orientation means how the object is turned. In simple language. How is it turned? Is it turned to the left? Is it turned to the right? Is it turned up? Is it turned down? Is it turned sideways? How is it turned as presented to us? Now this says the orientation can be different, but we can turn the objects, and in turning them we will see that they fit over it, or they would fit over each other. We can actually, if we are able to cut them out to prove that they would fit exactly over each other, or we can look for other clues such as the measurement of the angles. We can compare. Do they have the same kinds of angles, the exact same value for the angles that are given? We can look at the lengths of the sides. Are the sides the same length as in this object as in the other? If they are real objects that we have, in our hands, we can actually fit them over each other and see if it does. And we're going to do a little activity like that right now. So we're going to I have some objects, and we're going to see. Alright, so let's start with these sets. So I have 2 sticks of chalk, right? I put them together, and if you don't look carefully, you don't even realize that there are 2 different sticks of chalk, because they are so alike. They are identical twins. They are identical twins. See? Exact same length, exact shape, exact circumference at this top as the other top, as the bottom, whichever side you want to call it, top or the bottom. They are exactly the same. They are identical. So these 2 sticks of chalk are congruent. Likewise, these 2 pens are congruent. They are identical. Right? How about these 2 books? See, they fit nicely over each other. If I put one book behind the other, you can't see the other book. And if I turn it around, same thing. No matter how I turn them, you can't see the other book. Nothing comes up here or there. They fit exactly over each other. both in length and width, and if I put them like this, see, they are the same width in terms of how many pages there are. So these books are congruent, the pens are congruent, and the sticks of chalk are congruent. How about these ones now? How about these two books? Look at these two books. So if I take these two books, one is shorter than the other in terms of length. They have pretty much the same width, almost, but in terms of length, the red one is longer. This is thinner than this one. So they are clearly not congruent. They are not the same size in terms of length, width, height, nothing. How about these two? Are they congruent? No, they clearly are not. The geometric set is smaller. It's shorter in length and width, and height is actually smaller, much smaller than the pencil case. Alright, how about these two calculators? They look like the same size. Are they the same size? They almost look like the same size, but they're not. And this one is actually thicker at the top than this. So they are not identical. They are very similar to each other in many ways, but they are not identical. Okay, so they are not congruent. So when we talk about congruence, whether in terms of two lines, two polygons, two angles, comparing the angles, they have to be exactly the same for us to say that they are congruent. So let's look. We have these two triangles. Are they congruent to each other? Look carefully at them. Are they the same, the two same triangles? They both have a right angle. They both have a right angle. But this one is turned towards the right, this one is turned towards the left. Would you say that they are congruent? This has 30 degrees, 50 degrees at the top. 50 degrees at the bottom, 30 degrees at the bottom. But actually they are congruent. Remember, we said they can have a different orientation. One can turn to the right, one can turn to the left, one can turn up, one can turn down. That does not matter. What matters is the clues that we're looking for, the size and the shape. So they are both right angle triangles. They both have a 30 degree and a 50 degree angle. Yes, the 30 degree in this one is at the top and this one at the bottom. It doesn't matter. That does not matter. Right? We could orient this a different way and fit it over the other one. We could turn this that way and fit it over that one. They are exactly the same. How about these two rectangles? One looks bigger than the other, doesn't it? One looks bigger than the other. So, but when we look carefully, we see that they are just oriented differently. The length is turned this way in this rectangle, and the length is turned vertically in this rectangle. But they are the same rectangles. This has a length of 90 and a width of 86. Length of 90 and a width of 86. So even though at first glance this one looks bigger because the length is turned up, it gives our eyes the impression that it is bigger. You have to look more closer. You have to look more closely, and compare the actual lengths to see that these are the two same triangles. How about these two lines? One is oriented horizontally. One is oriented vertically, but they are both 12 centimeters. They are both 12 centimeters. That means they are congruent to each other. Here we have two more polygons. They are irregular and they are oriented differently. This is oriented to the right, this is oriented to the left and turned upside down. However, same 16 meters, same 10 meters, same 12 meters, so they are congruent. Here we have two circles oriented differently, but we are not given any measurements, but they are the same size, they are oriented differently, so we can assume though that they are congruent. And here we have two pentagons, two five-sided polygons. They are not regular, they don't have all sides equal, but these two are equal just like these two. We're not given any measurements. We're not given any measurements, but they have the same size by looking. We don't have anything else to go on, right? But by comparison, by looking, we're seeing two equal sides at the top, two equal sides, three equal sides at the bottom. So we're assuming for this one, based on what we're given, we can safely assume that these two are congruent. We would have preferred to get more detail, throw in some angles, throw in some measurements of the lengths and so on. But we're going to make the assumption, seeing that we are told these two are equal, these two are equal, these three are equal, and it appears to be the same size. So we look at what we're given and make comparisons in order to determine if the objects are congruent. And if we are able to cut them out and see if they fit exactly over each other, or if they are actual objects that we can look at and evaluate and see if they fit, see if they have exactly the same size and shape. Remember, the orientation doesn't matter. We can twist, we can turn them left, right, up, down, sideways. That's not the important thing. The important thing, are they the same size, right? Same length, same angles, same shape. So that's what we use to determine congruence. If you have benefited from this video, just drop a line to say thank you, miss. I would appreciate that. And I would love also if you would share the video so that other students can benefit from the information. If you have not subscribed, please subscribe and let me know if you want me to do videos on any particular topic. So I'll see you in the next video.